Okay, so here we have a vector that is 8 kilonewtons magnitude at an angle of 40 degrees. What we're going to do is we're going to resolve this force into horizontal and vertical components. Now to do that, we need to break this down into, using trigonometry, into this horizontal and vertical component. So the first thing we're going to do is we're going to create a right angle triangle, keeping the angle inside the triangle. Okay, so I'm going to use red for my vertical, so that comes down, because my vector is going down and to the left, so my vertical comes down, and then my horizontal is going to come across here to the left. Okay, now the way we label this up is we need to think about our trigonometry. So we've got SOHCAHTOA. Okay, so we know that the hypotenuse, which is the vector that we're given of our triangle there, is 8 kilonewtons. So we can tick that we know the hypotenuse. Okay, now our vertical line, our vertical arrow, is opposite the angle. Okay, so if we want to know the opposite, we can tick opposite. And because we have both of these, we know that we're going to use the sine function. Okay, so this angle here is going to be 8, the size of the force, times the sine of 40. Okay, we're then going to look at our horizontal vector, our horizontal component. And again, we have the hypotenuse, but this time it's the angle adjacent to the side adjacent to the angle that we're gonna find out. So we can tick the adjacent there. Okay, so we've got both there for the cosine, and we're going to label this one as 8 cos 40. And they're absolutely fine to leave them as that. There's obviously a number that goes along with that. It will have loads and loads of decimal places, but we'll just leave them as 8 sine 40 and 8 cos 40 for the time being, and we'll deal with any numbers further down the line. Okay, so that's that 8 kilonewton vector now resolved into its horizontal and vertical components.